welcome to Tuesday's edition of Cracking the Cryptic, where on screen you can see the puzzle we actually did yesterday on the channel. And that is because Mark has got something special lined up for me today. He wants me to open this one live on the camera, so that is what I plan to do in just a moment. Before I do that though, I want to say happy birthday to a couple of people who've requested a birthday shout out. So firstly to Chris Hart. Chris, I think it's your 27th birthday today, and your partner Ellie got in touch with us to say you might appreciate a happy birthday, so that is what I will wish you. And of course I hope you have a splendid cake. And also over in Washington State, I'd like to say happy birthday to Nicholas, and that's from your friend John. Other than that, I don't think I've got much else to tell you today. Just as usual, if you do enjoy the channel, please consider supporting us in one way or the other, whether it's by subscribing to the channel or by subscribing to Patreon. We'd be most grateful. Now, with all this said and done, let us see what Mark has got in touch with me. So I've got to paste this into the browser. Here we go, and we have got a... oh no, no Demono. Progressive Divisors by Demono, and a very, very empty looking grid. I mean, literally, I've got two cages and some less than signs outside the grid, or I suppose greater than signs on the left hand side. Right. Oh no, what the places is this? Right, let us have a look. We've got normal Sudoku rules apply. Progressive divisor numbers are numbers where the first digit is divisible by 1. That'll be any number then, won't it? The first two digits taken as a two-digit number are divisible by 2, and so on. Oh, good grief. Right. Okay. There is a 9-digit progressive divisor number in row 1 of the grid. Well, there isn't yet. Written from left to right. Each of the digits in row 1 is also in a distinct, non-overlapping, invisible region that sums to 3 times the digit's value. These regions may branch, and digits may repeat in regions if allowed by other rules. What? The size and shape of these regions must be determined by the solver. Right. Clues outside the grid. Right, which are the symbols, indicate the first n cells in the row column, read from outside in, are a progressive divisor number, where n is the digit in the cell next to the clue. Okay. The cages hold two-digit numbers that are either divisible by both digits, i.e. 24, I suppose 24 is divisible by 2 and 4, or neither digit, i.e. 98. No, I don't think 98 is divisible by 9 or 8. Okay. Good grief. Mark, you are an absolute rotter. This means he's had a go at this, and he's thought it would be funny for me to have to do it on the camera. I haven't got a clue what's going on here. I think I understand basically what this progressive divisor thing is saying. So that's saying, if we look at this row, and we try and have a 5-digit divisor number, then the first digit has to be divisible by 1. Well, it will be. The second, those two digits would have to be divisible by 2, so that would have to be even. Those digits would have to be divisible by 3, those digits would have to be divisible by 4, and those digits would have to be divisible by 5. And then in digits 6, 7, 8, 9, if we had a 5-digit progressive divisor number, that would be, these wouldn't be affected, other than by Sudoku, I suppose. So I think the problem I'm going to have here is that I imagine to solve this puzzle you need to know all these loads of rules of arithmetic. And I know some, but I don't know many. So what do I know? I know that if a number is divisible by 3, its digits have to be divisible by 3. I think the same is true of 9. So if you want to work out whether a number is divisible by 9, you add up the digits in the number, and then you you see whether that number is divisible by 9. And that I do remember from school, how you prove that. So, well, ish. So if you imagine a 3-digit number, any 3-digit number can be expressed as 100x plus 10y plus z. And then you just muck around with the first term. So if you, rather than saying you've got 100x, you could write 100x as 99x plus x, and you could write 10y as 9y plus y. So the whole thing could now be, and then you can factor out the 9. So you end up with 9 times 11x plus y. That's in brackets, plus, and then outside the brackets, plus x plus y plus z. And then obviously 9 could be expressed as 3 times 3 as well. But that first part of that expression is divisible by 9 and 3, therefore. And so in order to work out if that expression was divisible by 3, you'd have to work out whether the second part of it, x plus y plus z, is divisible by 3. Or 9 if you were doing it by 9. I realise I've explained that very badly. I will try and remember to put some cards on the screen to explain what I just said, because that will probably make it clearer. Right, but what else do I know? Do I know anything about rules about divisions by 4? No. 5? No. 6? No. 7? I bet there's one about 7, but I don't know it. And 8 I don't know. So this is probably going to be a fool's errand, I think. And I will spend the next hour and a half being laughed at. Right, but let's try and solve this then. So how do we even start the puzzle? There is a 9-digit number in this row. So this is the key row. And every other little pointy thing is saying that there's a progressive divisor number of some length in that row. So if this was an 8, we'd be saying that was this number here, an 8-cell number was a progressive divisor number. So these two would have to be divisible by 2, by 3, by 4, etc. You know the drill. So how do we start this? So as far as I can see, the first digit in this, the 9-digit progressive number here, this digit is completely free, although it's also part of a progressive number going down. Ah, right. That's even, isn't it? Because as part of our 9-cell progressive number, we know the first 2 digits must be divisible by 2. So this has got to be even. And I bet you that's the case for 4 as well, isn't it? Yes. For this number to be divisible by 4, this must be even as well. Right, so actually there's a quadruple in this row, corresponding with the even digit positions. Because in order for a number to be even, it must end in an even number. So now we have actually got a little bit of a start. This has got to be, these are odd digits. Right, so this one, those 3 have to be divisible by 3, which means the sum of the digits has to be divisible by 3. Oh, that does not seem restricted to me at all. Is that restricted somehow that in a way I don't realise? I mean, there seem to be umpteen possibilities of how that could work. I'm sorry, I don't understand that. Right, that one's divisible by 4. This one's divisible by 5. Right, I've got a digit then. That's a 5, isn't it? Yes, a number, any number that's divisible by 5 either ends in 5 or 0. So actually I've got a digit. Right, okay, so that's good. I view this as a great triumph. This is divisible by 6. Oh, I've just thought of something else. This one is in a divider going down. So this cell must be even, because however long this is... Actually, this is quite interesting. Let me just think about this for a second or two. Is there some restriction on the number of even digits in this column beyond the obvious? I know there can only be 4 even digits in this column. Yes, this is different. This has a different complexion to row 1, because row 1's... Oh no, am I wrong about this? No, I don't think I am. How can this be an 8? That's the thing I'm wondering. If this is an 8, what we're saying is that the progressive divider number will go all the way down the grid to here. But we know the 2-digit number here would have to be divisible by 2, so this would have to be even. The 4-digit number would have to be even. The 6-digit number would have to be even. And this digit, the 8-digit number, would have to be even. But we know this is already even, so we'd have 5 even digits in the column, and that doesn't work. So I don't know that I can say much about this beyond the fact that that digit is not an 8, and this digit, because this digit is in the progressive divisor number, even if this is a 2, there is a 2-digit number down here which must be divisible by 2, so this is even. So we've got 3 even digits now in box 2. And so if that's a 6, those 4 would be the evens and these would be the odds in the column. Okay, I don't quite understand what that's doing yet. So 7. I just don't know enough about the rules here to work out whether this can only end in some digits. I think that I can think of numbers divisible by 7 that could end in all these digits, so I don't think that's going to be the case. 8 we've already looked at. 9. Oh, I've just realised that there's the secret. Tells us that this digit is not really under any pressure, and the secret, of course, and I only tell this to my very special friends, is that any complete row, any complete column, and any complete box of a Sudoku, because it contains the digits 1 to 9 once each, sums to 45. So I know that that row sums to 45, and 45 is of course divisible by 9. So it doesn't really matter what's in this cell, that we know that whatever number we come up with that works for the rules of Sudoku will work and will be divisible by 9, which is quite cute. Right. So what on... right, so... right, hang on. Now, there was some other rule, wasn't there, about how these digits... There was something about 3 times the digits value. Let me read this bit. So, each of the digits in row 1 is also in a distinct non-overlapping invisible region that sums to 3 times the digits value. Right, so this cell is part of a region that sums to 15. These regions may branch, and digits may repeat in regions if allowed by other rules. The size and shape of these regions. What? So the biggest region along here, or the biggest in terms of the size of the digits we'll have to put in it, that wherever the 9 goes, that will have to be part of a 27 region. Wherever the 1 goes, it will need to be part of a 3 region. So it will have a 2 below it. Right, there we go. So there is a 1 in one of those 4 cells. So there is a 2 in one of these 4 cells, which means that's not a 2. Right. So now... what does that mean? So the 1 must have a 2 beneath it. The 2... Oh, bobbins. No, the 2 has options, I think, because the 2 has to be part of a region that sums to 6, which means it could have a 1 and a 3 underneath it, or it could have just a 4 underneath it. And then 3 will have to be part of a region that sums to 9. So that's not going to work. No. Okay. Good grief. Right. So, what do we look at next? I refuse absolutely to look at these cages. These cages, I think, are very clearly disambiguating cages for some very late stage of the puzzle when we actually know things about the world. Clues outside the grid indicate the first n cells in the row column are progressive divisor numbers. The problem is here, what use are these? Right, actually they are a little bit useful. Yes, okay. Okay, no, this is interesting. I'm going to label all of these that are pointing inwardly at this column, because I've got a 5 here. So if I try and make this a progressive divisor number, that's where this digit is a 5, 6, 7, 8 or 9, then I would need to put a 5 here, because this will need to be divisible by 5, and it can't be now, because I can't put 0 here. I can't put 0 in this puzzle, can I? That's... No, normal Sudoku rules apply. There is no 0. Right, so so these squares all have to be 4 or lower. And that's beautiful. Right, now I've got a quadruple in column 9, so that square is not 1 or 3. So this is 7 or 9, and that has to be part of a region that adds up to 21 or 27. Oh, bobbins. Right, so what do we do next? This must matter, mustn't it? So maybe this is a parity puzzle. Oh, sorry, not a parity puzzle, a high-low puzzle. Because I've got 1s, 2s, 3s, 4s there, so these all have to be high digits. Do I pencil mark that? I don't think I will yet. And I've got the same in column 1, but I need to be able to restrict that down. Then I'd have a quadruple in this column as well. Or know that this is a 2. Oh, no, I can do this. Right, yeah, that can't. Yeah, this is good. Right, this can't be a high number. If that's a 7, the progressive divisor number would include this cell, which would mean that this number would have to be divisible by 5, and that can't be a 5. So that can't be a 7 or a 9, I want to say, which means I've now got a quadruple, and that is not a 2. Now, if that's not a 2, 2 was accompanying the 1. This is a 3. I've got another digit. Because, let me just double check this logic. I'd worked out that 2 had to go underneath 1 in the top row, because it needs to be part of a region that sums to 3. Now, I'm just pausing then. I think it said something about non-overlapping regions, didn't it? So what I can't do is go 1, 2 like that. I hadn't thought of this before, but I think that's wrong. If I go 1, 2 like that, then this cell is part of 2 regions, because the 2 is also part of a region that has to sum to 6. That doesn't work. Right, so this is not a 1, that is a 3, which means these cells are not 3s, which means these cells are not 3s. Now, okay. So I feel like this cell needs to be a 6 now. Is that true? Yeah, I think I'm just going to get rid of the highlighting for row 1 for a moment, because isn't it true? Because each of these digits is part of a non-overlapping region, and none of those regions are one cell large, because even the 1 region needs to pick up a 2 in order to add to make sure its region adds to 3. So in fact, we could domino this, couldn't we? We could do this sort of thing. Just going to domino it, because each digit in the top row must be part of at least a 2-cell region. So that now this one has to take this cell, which can't be a 1, 2, 3 or 4, so it's at least a 5, but we know that we're heading up towards a 9 total for the grey region, because 3 times 3 is 9. So this is a 5 or a 6. Now if it's a 5, we have to get the 1 from here, which we can't do. So that's a 6, and that is a region. Now that's a region done. And look, that's not 6 anymore. What's that mean? This is just a fascinating puzzle, isn't it? It seemed completely intractable when I read the rules, but actually you can sort of make some progress. So this blue region must come out again, because we know it's adding up to at least 21. Oh dear, oh no. Having said it was a little bit tractable, I'm just Oh, this region adds up to 15. So it must come out another cell, because obviously that can't be a 10 on its own. This clue going up is part of a thingy thing region, a progressive region. That we've got 2 progressive numbers looking at each other across the bottom row. Does that somehow matter? Might matter at some stage, I think, but I don't see how to do anything now. Wow. This digit. Right. I don't think... I want to say this can't be a 4, but I'm now not sure whether that's true. If that's a 4, I know that's even. Yeah, that doesn't work, does it? Wow, it's quite difficult to see this, but I think it's true to say this can't be a 4. Because if this is a 4, I then know that this is a progressive number coming from this direction. So this needs to be evened for the 2-digit bit to work. So we'd have 1 even, 2 evens, 3 evens, 4 evens. But the 2 still has to live in the row somewhere, and it can't be here. So there'll be 5 evens in the row. So I don't think that can be a 4. So this is down to 1, 2 or 3. Now the thing is, I think it might be able to be a 2, because I've got 2's pencil marked into these 3 squares. So if this is a 2, that would be even, that would be even, and that would be even. So this would have to be a 4 or an 8. Oh no, I know. This is not a 2, is it? Because that can't be a 1. So the 2 was accompanying the 1 in this row, because it was part of the, wherever the 1 goes in the top row, it needs a 2 beneath it. in order to be part of a region that sums to 3. So when I got rid of the 1 from there, I could have got rid of the 2 from here. So this is odd now. And I'm sure that must matter for some reason. So if this is a 3, then this is a 2-digit progressive divisor number, so that's even. So if this is 3, that's even, that's even, that's even, one of the 2's is even, so we'd have to put odd numbers into those cells. But if this is a 1, then this is unaffected. Although that's quite interesting. If this is a 1, this is a 2, 3, 4 triple, and each of these would take in these digits in their numbers. So those would all be even, and that would be even, and this would be odd. So if this is odd, if this is 1, this is odd, and there's lots of oddness in this column. If this is 3, this is even, and that would be 1, 2, 4 down here. Yeah, there's probably some oddness and evenness resolution we could do in this column, but I'm not immediately seeing whether that's useful. I might come back to that if I get totally stuck. Goodness me, what on earth am I meant to be seeing here? Is there some sort of restriction? Like, if I knew this came to here, I would know this came to here. But this could be a 2. A 2 needs to be part of a region that adds up to 6. So it could have, it couldn't now have 1, 3. It couldn't have a 1, 3 pair beneath it anymore. So if that was a 2, that would be a 4. And that would be an 8. And that would be a 2. And that would be a 1. Lots of things would happen. I don't know. I really don't know. Do I have to look at this again? I know that, right, hang on. I know those 2 digits have to now sum to a multiple of 3, because 3 in and of itself obviously is divisible by 3. So using the 3-digit number rule, we've got to make sure these 2 digits are divisible by 3 to make sure that number is divisible by 3 overall. So I want to say that can't be a 9 then, because if that's, oh no, hang on, I'm going mad here. No, I am going mad. That's absolute nonsense. 9 plus 6 is divisible by 3. 7 plus 2, 1 plus 8. No, this is not the way to look at this. Oh dear. Right, let's look at the 4 number. If we look at the 4 number, but this is horrible. This is just horrible, because right. I can say about 4 numbers that I should only be looking at these 2 numbers, I think. Because if you imagine that this is a 4-digit number, then ignore these 2 numbers for a moment, and we've either got 3,200, 3,400, 3,600 or 3,800 here, all of which are divisible by 4 on their own, because 200, 400, 600, well, because 100 is divisible by 4 using 25. So I know that this part of this number is always divisible by 4, so I've got to make sure those 2 parts are divisible by 4. So easy. 12, for example, is divisible by 4. No, actually that is interesting. Why is that the case? That's weird. Okay, I don't quite see why this is right, but you can never, I can never use the 4 or the 8 here, can I? Because 14 or 18, for example, aren't divisible by 4, but neither are 74 and 78 or 94 and 98. So why is that? So I can see why it is obviously at low numbers. Then you're adding, then you're adding 20, you're adding 20 each time to get to an odd total. 20 is divisible, so you're always ending up with a sort of the same mod 4 problem. I do see that, actually. I do see that. Right, so this square here cannot be 4 or 8. So this is 2 or 6. Ah, no. Nearly. This is 2 or 6, but it's not part of a divisor number, so I don't know what this is. Oh, but if that's a 2, it needs to have 6, but no, it needs to have, I need it all to add up to 6, so I need either a 1, 3 or a 4 beneath it. No, okay. Bother. Right, let's think about 6 for a moment. So if a number is divisible by 6, can I do that same sort of trickery? I don't think I can, because 100 is not divisible by 6. So I don't think that's going to work. 7 scares me. 8 might work the same way. No, 8 won't quite work the same way, because 100 is not divisible by 8. 200 is divisible by 8. $200 is divisible by 8. Yes, okay. Hang on a minute. 200 is divisible by 8. So have we got the same thing then? Yes, I think I have got the same thing. This is quite hard to see, especially for me, and you'll have to apologise. I know that a number of you watching this are absolutely brilliant at maths, and this will be completely trivial for you, but right, this number here, let's ignore these 3 numbers in this 8-digit number. So this is an 8-digit number, and the last 3 digits here, let's just imagine they're 0. Then we know that this is some number of thousands. It's a very large number of thousands. But we know that any number of thousands is divisible by 8, because 1,000 is divisible by 8. So this part of this equation is not relevant. We've got to make sure that these cells are divisible by 8. So, and this is an even number. So this is 200, 400 or 600, all of which are divisible by 8, because 25 times 8 is 200. So this isn't relevant, so these two have to be divisible by 8. So 16, 72, 96. Is it the same thing again then? We can't use 4 and 8 here. 14, 74, 94, they are not divisible by 8, definitely not. 18, 78, 98 are not divisible by 8. Now, it is the same. It is the same. I'm not going to worry about why that is. It just seems to be correct. So this square here cannot be 4 or 8. So now I've got a 2, 6 pair in this row. That's so strange. So again, when you're dividing by 8, you're always going to have a remainder of 2, and then you're going to add 20 more to get to the next odd number. Yes, you're sort of taking 4 more, and then yeah, I can sort of see it. It's less clear to me than 4, but it's anyway. We've definitely got a 2, 6 pair in this row, so I have got another digit. I've got a 4 here and another digit, an 8 here. So this now seems to have to be 8, which I don't know why that is. I can't remember why. Oh, that's because it had to be even, did it? And we knew it wasn't a 2, and it's not a 6. Right? Okay, so I'll have that. That's an 8. This is part of a region that needs to add up to, a region that adds up to 12, and it does. So there we go, we've done that region. This region has got an 8 in it, and it needs to add up to 24. So that's got to be bigger. It's got to grow to at least this one. Oh, can that be 7, 9? Perhaps if this is a 1. So maybe we can't rule out that being a 3-digit region. Right, so what's this done for me? I don't know. It's obviously useful. I've got the 4 and the 8. But oh, the 4 is in a progressive number, so that's got to be even. Aha! So that's a 2 or a 6. This cell is in a progressive number as well, because it must, in order to get to a 4-digit progressive number, we've got to get through the 3-digit progressive number. So these two themselves are divisible by 3, so this must be divisible by 3. So that's a 3, a 6, or a 9. And that's very, very annoying, because all of those seem to be possible. Okay. I think I am now going to pencil mark this column, because I've got this quadruple here, and we're getting to the point where Sudoku might become important. So these are 5, 6, 7, 8s, and 9s. Or not, as the case may be. Mark, you are such a so-and-so, you really are. I've been in this position with Demono puzzles many times, it feels like. They're always very interesting, but they're always very hard as well. Literally, I haven't got a clue where I'm meant to look. I've got to look at somewhere. Oh. Those 3 digits have to be divisible by 3. No. Oh, I can get rid of 9. That's all I get for that. That revelation in my head. This can't be 9. Because 9 plus 8 is 17, and that's not divisible by 3. But unfortunately, 7 plus 8 is 15, and that is, and 1 plus 8 is 9, and that is. So this is, so now there's a 9 in one of those, so that's not a 9. 9 is definitely in one of these two cells in row 1. Right. I am going to allege something here, which must be true, mustn't it? Any number that's divisible by 6 is divisible by 3. That is what I'm going to allege. And I realise I make some sweeping statements on this channel, but that one feels fairly solid. And that means that any number that's divisible by 6 also must have digits. Because it's divisible by 3, it's its digits must sum to a number that's divisible by 3. And because we know those 3 digits are going to be divisible by 3, these 3 digits must be divisible by 3. And 4 plus 5 plus 2 is not divisible by 3. He says, no, it's not. So that's got to be a 6. And that's got to be 15. And that is divisible by 3, which means this is a 2. Now the 2, I want to say that has to have a 4 beneath it now, because it can't have a 1-3 pair beneath it, because the 1 and the 3 are not available. So doesn't this have to now be a 4 to make its region add up to 6? That feels like it's probably correct. So now I've got a 6 here, which has to be part of a region that adds up to 18. So this can't be a 12, so the grey region must come down. But, okay. So now we are going to say that I don't know. I don't know. This is not a 6 anymore by Sudoku. This is down to 3 or 9. Oh, I tell you what, that's not a 2. So where does the 2 go in row 2? Not here. That's beautiful. That's going to be so good, because that means the 2 can only go here. Because the 2 had to be beneath the 1. So that's the 2, that's the 1. These squares are now a 7-9 pair. The 1 and the 2 are a complete region. Whoopsie. What does that mean? It means that. I know what I do know what it means. I do know what it means. Look, let's look at these 3 cells. Now, the question I want to ask is whether it's possible that none of these cells is a 1. If none of these cells is a 1, they're a 2, 3, 4 triple, which means in each case there is a 2-digit number or longer, but there's got to be progressive numbers that are those long, which means all 3 of these cells would have to be even, and they can't be, because there are only 4 even digits available between the numbers 1 and 9. So there must be a 1 down here, and if there's a 1 down here, and there is, that means that's a 3, which means that this square, we now know we've got to make this a progressive number, so these 2 together have to be divisible by 3. So this could be a 5, it can't be a 2, or it could be an 8, which it can't be. So is that just 5, or am I going mad? That's my question. No cheeky comments, please. I don't see how that can not be 5. I think it's got to be 2 or 8 if it's not 5 to make those 3 digits divisible by 3. So I'm going to allege that's a 5. Now, these digits have to be 1s, 7s and 9s in the row, and that can't be a 1. And that seems to be as far as we can take that. This now is not a 5 or a 7, look. So this is a 6 or an 8. In fact, we know there's a 1, 6, 8 triple along here. Do we know what happens to this region? This is either at... Oh, yeah. This is either 21 or 27, so it's got to be 3 cells. So it's taking that cell in. Which I'm sure is somehow important. Neither of those are in progressive divider regions, though. So we've sort of done this clue now. I almost want to tick them off when I've done them. This has to be divisible by 4. We know its first 2 digits always will be. 4,800 is divisible by 4 quite clearly. So 32 or 36, oh I see, no that's working isn't it? 92 is definitely divisible by 4, yes it is, and 96 will therefore be, so this is not resolved. This could still be not just 879, look, that would work I think. Right, so we've got to think harder again. Oh, I can take 3 out of all of these. Let's do that and see if that helps. So this is a 1, 2, 4 triple. Right, oh, this is beautiful. It gives me this digit. This is so beautiful. Right, look at this column. I know that 2 of these 3 digits are 2 and 4, and therefore they're going to extend, you know, something like that. In other words, 2 of these 3 digits are even. Now they will accompany their friends, the 2 and the 4 up there, to create a line of evens. So 4 of these 5 highlighted cells are even, and they're all the evens for the column, so that's got to be a 1. It can't be even. And the other thing we can say therefore is that those 3 cells are odd, and they're not 1. So these are 3, 5, 7, and 9. So there's got to be a 6 and an 8 in 2 of those 3 cells. Which is probably resolvable somehow. Okay. There's got to be a 4 by Sudoku in one of those 2 cells. Is it Sudoku we do now, or is it something else? We need 15 here. Right. That can't be a 9, because that would require a 1 beneath it in this region, and we can't put a 1 here. So this is 1 or 7. So if this is 7, I need to either have a 1-2 pair, which I could have a 2 here and a 1 here maybe, or I could perhaps have a 3 here. Oh, bobbins. Right, what about this one? This is adding up to 18, but there's loads of flexibility I think there, and this one we know is massive, so that's not helping. And this one is done. It's really tricky, isn't it? It's really tricky to see how to use these clues together. I'm not sure whether I'm meant to be looking at... Oh, I know what I could do here. I'm going to do it. I can work out whether that number... It's not going to be possible that this massive number ending in 7 and or 9 are both divisible by 7. Only one of them will be divisible by 7. I'm working this out. So 38 has a remainder of 3. 31 has a remainder of 3. 36 has a remainder of 1. 15 has a remainder of 1. 14 has no remainder when divided by 7. So that's got to be a 7 in order for that to work. So that's a 7. That's a 9. That's ridiculous. So I've got the progressive number now. The top row is done. The number is very high. 381,654,729. So now I know that these the blue squares have to add up to 27, and so far we've got 12, so we need another 15, which could just be 8 and 7 by the looks of things. What about that one? This has got to be 21, so that could be 7581. If it's 756, we'd need another 3, which could even be there, or it could be here. Right, sorry, this is bobbins worthy, isn't it? That's not helpful. That's a shame. I was quite excited about getting the number. Right. Wow, okay. So, so where do we look now? As usual, I don't have a Scooby-Doo. I really have not got a clue where I'm meant to look. If that's a 4, do I get into trouble with even numbers in this column? I'd have to go 4, 2, 8, 6. And this would be a very well, this would be a 1 in this cell, which would make this progressive divisor indicator a little bit of a comedy, although I suppose it was necessary for us to restrict at least one more of these to get this quadruple that we got going in this column. Yeah, okay. What you can't do here is make this a 2-4 pair, because if that's a 2-4 pair, these two cells both have to be even, because we've got a 2 and a 4 there, for example. So we've got definitely got to make these two cells even to make the 2-digit divisor numbers work in these two positions. So those are even, they're not 2 and 4, so they're 6 and 8, and that's going to clash. So one of these is a 1, and that's not a 1. Now that means that cell is even, so it's not, so that's 2, 4, or 6. So that's 2 evens, and there's going to be another even down here corresponding to whichever one of these is 2 and 4, 2 or 4. Oh, hang on, have I broken this now? Well, that can't be a 4 now, because if it's a 4, what on earth? I need this to be even to make the progressive divisor number working, but it will have to be a 1, and that's not even, so that's not 4. Does that? It works the same way with 2. Right, there's a 1 in the corner. Right, that's lovely, actually. It's really quite interesting the way that unwound. Oh, oh, that's not a 1. But this 1 is not telling us anything in this direction now. So I was hoping I might get some logic in the bottom row, you know, if these were somehow overlapping or something, but I'm not getting that. So right, so now we're going to have to think again. But I don't know. I really don't know where to look, I have to say. What numbers have we not looked at yet? Oh, aha, I've got another digit. That digit is a 9, because this is quite easy. Well, it's easy for me to miss, but that's a 3-digit divisor number. So that we've got 3 and 6 here. We know a 3-digit number to be divisible by 3. Its digits must themselves, if summed, be divisible by 3. So the only way we can keep this sequence to mod 3 is if we make that 9. Now that's going to give me a 7 here, and oh, lovely! This is beautiful. And a 3 here. Suddenly I've got loads done in the top rows. This is a 4-5 pair. These two squares now are 2 and 7. So yeah, I can do this. I can do this. I've got 15 here. So if I add 7 to that, that's more than the 18 I need. So that's got to be 2. And that's got to be 7. But I still need one more here, which must come here, mustn't it? To make 18. I can't get it from those two squares. So that's got to be grey. And there we go. We've got another whole load of digits off the back of that. So now in the purple region, I need 15. At the moment, I've got 13, so I need a 2, and that's going to have to go here, and that 2 gets me a 6, and that's purpled, and that means I get some more things done. My 8 region, oh, it doesn't have a 9 here now, so my 8 so is this done then? 8, 7, and then this could be a 4, 5 pair. Ooh, I've had a horrible thought about that. Right, we might have to watch this. Because what if this puzzle relies on this being a 4 or 5, or this being adding up to 5 or 4 or something? When it's possible, I think, for us to get to the right total by just taking this digit. I hope that that's not going to be necessary. We better keep an eye on that, though. I think this is done, but if the solution, or if the logical solution requires us to deduce that this is, say, a 4 or a 5, in order to allow that to be the region, then we've got a problem, because this, I think, is freely available to green. Right, that's not 6 now. Oh, I've got a 2, 4 pair and a 3, 6, 9. Right, so these cells are known. These are 5, 7 and 8, I want to say. 5, 7 and 8 into those cells. We've got... I'm almost coming up to an hour. That does not surprise me one iota, I have to say. This is surely not an easy puzzle. 1 is in one of those 2 cells by Sudoku. 2 is in one of those 3 cells by Sudoku. 6 is in one of these 3 cells by Sudoku. 1 is placeable in this box. It can only go there by Sudoku. So 1 is placed here. That's a 1 by Sudoku. So that's not a 1 anymore. So this is even, because that's in a progressive number. Oh, that is possible. That's even as well. No! Oh, this is so clever. Right, I know what that digit is. So there's 2 things to note. Firstly, because this is a 2 or 4, this is even. Let's just deal with that firstly. That's a 6 or an 8. But look, if this is a 4, that number requires this to be even. But this sees 2, 4, 6 and 8, so it cannot be even. So this has to be a 2, which means that then we've got, then I've got a 4 here and a 1 here. Now the 4 is going to require some evenage in this row. So this is now a 6 or an 8. So we've got the 6, 8 pair now. This is now odd, and it's not 1. So this is 3, 5, 7 or 9. This is even, because it's the 4-digit number to there must be even. And oh yeah, and this can be 2, because it doesn't see this 2. So that actually gets us the 2 here. This can't be a 1, I've just seen, so that's got to be a 1. How many 1s have we got? All of them. I've got all the 1s. 2s? Not all of them. No, not all of them. Do I know that digit? Maybe not. Okay, sorry. Starting to mumble. Right, so that's very exciting. But has it actually done enough for us? I can reduce the options for this cell, can't I? Because I need these 3 together to add up to a number divisible by 3. So, really would be good if I could. Right, so 6 obviously would be divisible by 3 on its own. So that would force this to be 2, 5 or 8, which would only 8 would work, I think. Can this really be 8? Possibly. Right, so on the other hand, if this is 8, these are divisible by 3, and then this needs to be mod 3, so it needs to be 3, 6 or 9, all of which seem to be on the table. That's really disappointing. So this has got loads of options, is what we're learning. This one is only 2 length 2, so we can't do anything there. So what we've got to do now, he says, without a clue, is to go, those are 5, 7 and 9. Or can we do more with these now? Oh, I tell you, I don't think I've looked at these since I got this 1. I'm not sure. So this one has to add to 21. Oh, look, that could be 8, 1. I think I did look at this. 8, 1 like that would work, wouldn't it? And then that would have to be a 6. So we'd have to get to another 9, not including this digit. So we'd have to take this digit. Oh, these can't be 9s, obviously. There's a 9 already in the column. Actually, that is tricky. That is tricky. I'm just going to look at this a bit more carefully. If this is an 8 and this is a 6, then I've got then to get this total to work, I've got to pick up one more, which it can't be this one, it's too far away, so it would have to be that one. So this region is now forced, but now I have to pick up this in blue. So blue is now of size 18, needs to get to 27, but this can't be 8 then because it can't get the 1, and it can't be 7 because it can't get the 2, so it would have to be 5, whereupon I need 4 more. And I can't get it, can I? I can't get it there. I can't get 3 and 1 together orthogonally. So this is not right. This doesn't work. So this is quite powerful then. So this is not 8, this is 6, and that's 8. So now I've got, oh I see, now I've got 18 here and I need 3 more, and I could get it either here or here. I don't actually know which of those. So I can't force this to be a 3, which is annoying. Right, but now I've got rid of 8 down there, look. So how does this one work? I've now got 20 here. I need 7 more. But I could now take this one, but then if I took that one, I'd need 6 more without using the 1 or the 2, or that's not going to work, is it? That's impossible. So I don't take this one, I must take this one, and I can't do 5, 2, so I have to take 7. So that is a 7, and it's finished. That is finished. So we can draw a line around it. This cell here is not 7. 3. Hang on. This must be now done, isn't it? How do we do this? 6, 5. Oh no, it's not. I can't lock the 5. I was thinking maybe I could get the 5 in there and then get that to be a 5, but I can't. This is not 7. Maverick is clip-clopping a horse outside today, which is a lot quieter than the normal aeroplane action. Oh dear, I'm totally stuck again, aren't I? We can... So have I done... Oh, well, this is interesting. So this can always get this. So if this is forced to be a 3 to get a logical solution, that's also a problem, given that this can be the 3 that the black needs. So we've got to keep an eye on this digit and this digit in the finished puzzle. And what were the cages? I can't remember. They were the things I thought I should leave till the very end. The cages hold 2-digit numbers that are either divisible by both digits, or neither digit. Right, so that could be 3, 6, couldn't it? That would be divisible by both numbers. 5, 6, 56. That's divisible by neither. 96. No, that doesn't work. That is divisible by 6, but not 9. Oh, right. Okay, here is a question that's interesting. How can that be a 5? That doesn't work, does it? Because obviously a number ending in 5 is definitely divisible by 5, which means it must be divisible by its other number. Well, 35 isn't divisible by 3, 75 is not divisible by 7, and 95 is not divisible by 9. So that's not going to work. So this is a 6. That's very clever. Right, so 6 here. So now 5 comes out of those cells, which creates a 3-9 pair, which means these are not 3s or 9s. It means this isn't 5. Oh, so this is lovely. Okay, so exactly the same logic must apply here, mustn't it? Can we put a digit in here that means that this... I'm just going to check this. 3, 4. So what I'm thinking about is if this is 5, is it possible to put a digit in here that works? 3, 4, 45 isn't going to work, is it? Because 45 is... Oh, you can never put an even digit here, because obviously a number ending in 5 is an odd number. So we can automatically disregard anything even we're trying to put into this square. 3, 4, 5, 6 is we can rule out. 7 we can rule out. 8 we can rule out. 9 is not going to work. This does not work. Right, this is good. So this is not 5, which means that this is 5, which means this is 5, this is 7. Now does this work? 56 is not divisible by 6, and it's not divisible by 5, so that does work. Okay. So what do we do now? I don't know. A test. Every little deduction is hard earned here, let me tell you. I've got to put a 4 and a 6 and an 8 in. Oh, 6. 6 must... Oh, hang on. How long has this been available? I don't know. I'm not sure if it's been available for a while, but it does seem to me that the only place 6 can go in this box now is here. So I'm going to put it in. So that's a 6 and that's an 8, which means that's not an 8. Oh, and of course, that's totally useless. Look. So now we knew these 3 digits had to be mod 3. 4 plus 8 are mod 3, and that's 3 or 9, and we only get to eliminate the 6, which is very annoying. So these are 2s, 3s, and 9s. And these squares here have got to be 4s and 8s. So I'm sure there's some way we can resolve this a little bit further. Oh, 5, 7 here are looking at that square, which is an 8. That's beautiful. That gives us a 5 here and a 7 here, which disambiguates my 7 and 9. Come on. Holy moly. Come on. Come on. This is nearly yielding. Come on. I'm actually quite excited about this. 3, 4, 5, 8 into these cells. I'm going to label these up. 3, 4, 5, 8. That's not 5. That can be anything, I think. This one can be not 5 again. So 5. Oh, I see. It's Sudoku. Right, that's a 5 by Sudoku. So these are from 3. Whoopsie. These are from 3, 4, and 8, like they're friends. And we don't get any help about those. So is it this digit then? So 39 would be divisible by 3 but not 9, so that doesn't work. I'm saying that, but I'm far from confident that that's... Have I definitely understood this rule correctly? 39 is definitely divisible by 3. It's not divisible by 9. And that's not right, is it? So that cannot be 3, which means I've got a 4, 8 pair here. It means this square, I think, is a 3. But that doesn't really help me. Now, 49 is not divisible by 4, and it's not divisible by 9, so that works. And 89 is not divisible by 9, and it's not divisible by 8, so that works. So this is a 4 or an 8, but there's a 3 up here now, which does sort out my 3 and my 9. So 9 is in the domino up here. So this is 4, 8, or 9. What have I not done? I've got, this is only a 2-digit number. 26 is divisible by 2, so that's fine. That's a 1-digit number. This was the mod 3 number. Oh, yeah, but 4,800 is divisible by 4, so these two have to be divisible by 4. So 32 is and 92 is, so that's not going to help us. This is a 1 going vertically, that doesn't matter. Oh, okay, right, hang on, I've not figured out these two. So one of these is a 4, and that's going to require an even digit in its 4th position. But that can be even, I think. What about that one? If that's a 4, that has to be a 2. It can't be a 2, this would have to be an 8. I don't know. I'm not seeing anything there. There might be something. If oh, this right. This is not a 3, is it? Because this is a 2 or a 4. So this is even. So it's a So is that a 2 or a 4 then? It sees 6 and it sees 8. I think it is. So there's a 2, 4 pair in the row, which places my 2 over here. Beautiful. Right. So now I've got to put a 4. Oh, I don't believe it. A 4 in one of these is still okay. 2, 3. Have I got all my evens in this column yet? Not necessarily. Sevens down here. Sevens down here. X-wing on 7s. 5s. Oh, come on, Simon. That's not an 8. Okay. I'm sure it's going to be Sudoku, isn't it? It's going to be Sudoku that's going to get us out of trouble here. 3, 4, 6, 9. Oh, that's a 3 or a 4 only, because it sees 6, 9 in its column. So that's just Sudoku on this cell. Wow. Right, let's come back to this. Is this a 4? If this is a 4, we've got to put an even digit here, which would have to be 8. That would make this 4 and this 3. This would have to be even, but it could be 2 or 6. And then these 3 squares would have to add up to something divisible by 9. But that could still be 6, I think. Yeah, I've got to put, in fact, I've got to put 6 in this row, don't I? The 6 has to go in one of those 2 cells, and that will itself be divisible by 3. So 2, 4, 6 looks quite likely there, actually. Let's try the same thing here. So if this was 4, this has to be even. 2, 4, and it's got to be 8. Which would do what? So then... So then this digit becomes very restricted, actually. Because now, because 2 plus 4 is divisible by 3, because it's 6, this would have to be divisible by 3. And it can't be 3 or 6, so that would have to be 9. So, this breaks the X-wing on 7s. Oh, good grief, this is not easy. Right, if that's 4, I want to allege that I can't put 7 basically in this X-wing anywhere. Well, it's certainly not in this row. I've got 4, 2. I have to make this 8 because this is a 4-digit progressive number. Now, these 3 as the 3-digit progressive number, this has to be mod 3. So 3, 6 are out. That has to be 9. And now I have to put 2 7s in row 9. Or to put it a different way, I can't put a 7 at all in row 8. So this is wrong. This does not work. So this cell is a 2. This is a 4. This is a 4. This is a 9 by Sudoku. This is an 8 by Sudoku. This is a 4. This is an 8. This is a 4. This is a 3-8 pair, but we know this is evens. This is 8. This is 3. And surely now we've got somewhere, haven't we? So this is a 2-6 pair with a 2 here. So that's become a 2. That's become a 6. The 4 here fixes the 4 and the 5. That means this column needs 3 and 6 into it. I don't believe it. It's not resolved. And this column needs 1. No, it doesn't. It needs 5, 7 and 9. And that's got to be a 9 by Sudoku. So this becomes 5 and 7. This column needs 3, 4 and 7. So the only place that 4 can go in it is right at the top there. And this becomes a 3-7 pair. Slightly worried about this now. This looks a bit deadly-ish. I'm sure it's not. Oh no. Okay, so now we need 6, 8s and 9s here. So that's a 6. Aha! So that's a 6 and that's a 3. And this is 8 and 9, which is resolved. And that fixes the 9 and the 3 and the 3 and the 7 and the 7 and the 5. And I think I've solved the puzzle. Yes! Oh gosh. I'm so relieved about that. Mark, you are an absolute beep. That was, well, it was a brilliant puzzle. It was a brilliant puzzle, but it was monstrously difficult. Now this is interesting as well. Look at my what was it, 24 region there. It can't get 24 by coming to this cell. So that's fine. And what was the other thing I worried about? How this, yeah, this can't get 3 any other way. So it only gets it by coming this way. And in fact, therefore, we need to darken that cell to really complete the puzzle properly. So the top row now is perfect and has all its regions built. What? I mean, it's an extraordinary idea for a puzzle, Demono. Extraordinary. And the execution of it is so thematically consistent. You know, we kept having to use the very basic rules. I suspect some of you will know rules that will allow you to devastate this puzzle. But unfortunately, those rules were not available to me. I only knew my 3 rule, converting that into my 9 rule. And that's about it. And that meant it was very difficult, but it was super interesting. Loved it, to be honest. Just relieved I could solve it. Thank you so much for sticking with me, if you're still with me at this point. And we'll be back later with another edition of Cracking the Cryptic.